Okay, so just going to look at the equation of an exponential. So the word exponential means power. So an example of an exponential would be like 3 to the power of x. Now that's the basic equation. You can write this down in your book. The basic equation is y equals a to the x. Okay, the basic shape will look like that. Okay, and it will always go through a 1 on there. Okay, so this one here, basic shape, is like that. A way just to remember that is if you look at the 3 and you drew a thing like that towards the power, that would be the shape of the graph, and it goes through 1. So the y-intercept equals 1. Apologies for my hiccups. Y equals x to the 2. So that's the same thing, it's just powered. So if you drew it like that, that's what it will look like. So it'll go like that, goes through 1. The difference between the 2 and the 3, if you put that into Desmos, you would go y equals like 2 to the x, or y equals 3 to the x. Have a look and think about what will happen if you keep making that number bigger. Okay, so what you might have found is that it just gets steeper. So 2 to the 3 will go up quicker than, it'll just be steeper, go up quicker than 2 to the 2. And 5 to a power will go up quicker than 3 to the power and 2 to the power. So this one, once again, the y-intercept equals 1. Okay, now just a couple of things, if I change a couple of things, like if I made that minus 2x instead of to the power of positive 2x, put it into Desmos and have a look. What do you think will happen if it becomes a negative power? Okay, so if it becomes a negative power, it just goes down instead of going up. The y-intercept is still at 0, 1. It still intersects the y-axis at x value 0 and up 1. If you had 3 to the minus x, that would be an exponential going down through 1. Okay, so yeah, just have a play around and just put in the minuses and see that it's all the same basic graph through 1. Okay, what do you think would happen if I chucked a minus in front of? So put it into Desmos and have a look. And then put this one into Desmos and have a look. Okay, so what you would find, instead of going here, it will actually flip across and go here. So it flips and it's like upside down. So it's an upside down one. Just like the parabola, it turns it upside down. So y equals minus 3 to the x would turn it upside down. Still goes through 1, but it will turn it upside down. And the other thing that I'd like you just to make a note of, and you can do this into your book, if I have y equals 2 to the x, like we know it's a positive 1 through 1. Now, if I added 1 to that, what that means, it will go up 1. So instead of being through 1, it'll go up 1, and it'll be through 2. And it'll look like that. Okay? If you have y equals 2 to the x and you minus 1, so normally, this is the normal one, I'll do it in pink, it goes like that. If you have minus 1, that number at the end, the minus 1, that will make it go down 1, whereas the plus 1 make it go up 1. See how I put a dotted line 2 there? That's because here this is the line that it nearly cuts but never gets to. It's called an asymptote. This one, when you move it up, that whole line will move up. So it'll sit on top of 1. Okay, so if you move this one down 1, instead of being at 1, where do you think it's going to go? So put it into Desmos and have a look. Right, so it'll go down to 0 like that. Okay, and what will happen, it actually never will go below -1 now. So it stops at -1. Never actually cuts it, but stops at -1. So for this one here, the new y-intercept is 2, whereas this one here, the y-intercept now becomes 0. So enter a few different ones, like -3x, 3 to the -x, 3 to the x, 3 to the x plus 1. And just have a look on your graph on Desmos exactly what's happening. So 3 to the -3 to the x, yeah, that will flip it, still through 1. With a negative up there, that's one that comes down through 1. This one's a positive through 1. And this one will move up 1. So it actually goes through 2.